Okay. Got an item. Special breed of people in that island. Okay? They never die. They never reproduce. Okay? So. We got 1,000. Okay, I think I said 1,000. We got 1,000. Thousand immortal non-reproducing people on an isolated island. Five hundred of them are sane right now. And 500 are demented. Okay. Tomorrow. Ten percent of the same. Will become demented. It's an interesting line. Everybody's immortal, nobody gets hurt from that. We got all these demented people running around, okay? And 10% of the same people become demented. So just show me with your figures, how many sane people are going to be demented tomorrow? 50, right? Okay. That's, everybody at least has a 5 there. We're not necessarily sure what to do with the 0. Okay, but that's okay. So that's 50, 10% of 500 is 50. And 20% of the demented become sane. So my question is, how many sane and how many demented will we have tomorrow? Okay, so everybody is calculated. Ten percent of 500, 50, 20% of 500 is 100. Okay. So 50 of the same become demented, 100 of the demented become sane. Okay? So how many sane and how many demented are we gonna have? Well, we can draw a picture. We've got here's the same. Here's the demented. 500 of each. Now, I draw a little arrow there, it says that 50, these guys are gonna go over here. Right? And 100 of these people are gonna come back over here. So the same will lose 50, but they're gonna gain 100. Now, if you lose 50, but gain 100. Start with 500. You lose 50, you gain 100. How many are you going to end up with? So. We write that, this is 500 minus 50 plus 100, that's 550. Okay. And then. Reasoning it out simply, we end up with 500 minus 100 plus 50 equals 450. Better. Okay. So now we have. Well, okay. What happens during the next transition? What happens in the next switch? I say, what will we have? What I mean is, without using up too much board space and taking up too much time writing it, that means how many sane and how many dependent, right? Same question. The day after tomorrow. Now we know how much we have tomorrow. So we use those numbers to figure out how much we're going to have on the next day. Okay. Now, having a little trouble doing 10% and 20%. So if you're having trouble with that, you better have a calculator. Should be able to do it in your head. That's fine. Ready to calculate. Okay, so 10% of 550 is 55. 10% of 450 is 20%. 450 is 90. Okay. Agree? I thought I saw the page. Just making sure. Okay, good. So we're going to lose 55, but we're going to gain 90. That's a net gain of 45. So we end up $595 same. I said 45. And I'm wrong, it's 580. It's 35. Okay. 90 minus 50 is 40, 90 minus 55 is 35. So it's 585 saying 415. We made a note, but that still adds on to 1,000 because you're not losing anybody. Just going from one group to the other. All right. Now do this multiplication for me. If you have trouble with the numbers, just write out the details of the calculation. Like this number times this number plus that number times that number. Okay. So what this equals is. Point 90 times 500 plus 0.205. Now, I think somebody put these columns, when you multiply a row by a column, as we saw in the support course. This is what you get, okay? Multiply this by this, multiply this by this, and add. Now, when you add them, this is 450, this is 100. We add those up, we get 550. That's how many sane people you have after the first transition. That's what we got over here. Okay. And whatever way we reason it out. So the matrix gives us a compact way of calculating this. Okay. Wrote this out. What's that going to equal? Again, if the arithmetic gives you trouble, just write out the numbers. And I'll do the arithmetic for you. Okay, so what we get is and on how to multiply matrices, this part is simple. And then if we have trouble with the arithmetic, we get the calculator. We're going to get 554.50, which of course is everything that we have here. Okay. Now, if we want to calculate how many we have tomorrow, a day after tomorrow, and then, so this is how many we have today, 500 of each. This is how many we have tomorrow. This is a number saying this is a number in that. Oh, I think I know that. Okay. Now, we take the same matrix. Times the 554. Then we end up with 585. 415. This is how much we have the day after tomorrow. Okay. Now, there's another way I could write this out. It's similar, but it's different. Where did the 550, 450 come from? The 550, 450 is this. Okay, so I'm going to put a colored circle around this. Not a circle anymore, it's a bubble. Okay. So this is the same as this, right? And this is just a calculation you do to get it. So instead of 550, 450 here, I'm going to write this as okay. Because this is the calculation we did to get the 550, 450. Then we multiply that then by this. And now this calculation is identical to this one. But we kind of kept the history of where we got the 550, 450. Okay. Well, this matrix is the same as this. So we can write this out as this matrix times itself is the square of this matrix. And we multiply that by the 500, 500. Then if we want the number the day after that, we multiply by the matrix again, and we have the cube of the matrix. If we want the number we're going to have 10 days from now, we'd have to multiply by this matrix 10 times, which is like multiplying by the 10th power of the matrix. Okay. So we multiply by the 10th power of this, and it would tell us how many we have that far down the road. Now, there are really neat things you can do in linear algebra to get powers of matrices. But that involves matrix transformations and eigenvalues, all kinds of foolishness that we're not going to get into in this course, and that you're probably never going to need to see. Let's just do, because it just works. Of course, we have trouble showing that it works, but yeah, not really doing the arithmetic or let a calculator do it. What does it mean? Square of the matrix. How would you calculate the square of the matrix? Okay, now there's an important idea. To square something, what do? Well, we had to talk about it. Okay, how do you square 5? Well, no, 5 times 5. Okay, that's good. Okay, How do you square x plus two? Well, x plus two times x plus two. Well, how are you going to square this matrix? By extension, you're going to square this matrix by multiplying it by itself. I don't really need the zeros on the 0.90 and the 20. 0.9 and 0.2 suffice, and 0.1 and 0.8 are sufficient. And just for sake of space, I never leave myself enough. I'm going to write it out like this. Okay. Now you just learned how to multiply matrices. So you take my word for it. Well, 0.9 times 0.9 is 0.81. 0.1 times 0.1 is 0.01. Wrong. I get 0.82. No, so that was really going ahead thing. 0.2 times 0.1, right? 0.9 times 0.9, 0.2 times 0.1. Comes out 0.83. Okay. No excuse for that. Okay. Then 0.9 times 0.2 times 0.2, 0.8. 0.9 times 0.2 is 0.18. 0.2 times 8 is 0.16. That adds up to 0.24. Okay, then multiplying the second row by the first column, we get 0.9 and 0.8, which is 0.17. And but second row by second column, it's 0.02 and 0.64, which is 0.66. Now I'm going to point out an important thing about this matrix. All of these matrices, if I add 0.9 and 0.1, I get 1. If I add 0.2 and 0.8, I get 1. If I add 0.83 and 0.17, I get 1. If I add 0.34 and 0.66, I get 1. So, first of all, the columns of the original matrix add up to 1. Each column adds up to 1. And the columns of the square matrix add up to 1. And the columns of any power of the matrix add up to 1. So no matter how many times I multiply by this matrix, multiply the 500 by this matrix, I'm still going to get a total of 1,000. Right? That's what makes these people immortal. Okay. Well, actually, the fact that they're immortal is what makes this matrix, makes the columns add up to 1. We always get the same total number of people because this column always adds up to 1 and this column always adds up to 1. I'm not going to try to explain that because that's a little hard to understand and it goes a little beyond the scope of what we're doing in this course, but there it is. Now, since the square of this matrix is this matrix, if I do this calculation, it's the same as just multiplying this one matrix, squared matrix, by 500, 500. And that's going to equal, it has to equal, is 585, 415. So if all we want to know is how many sane and demented people we have 2 days from now. If we have 500 of each today. We just square this matrix. And multiply it by 500, 500. Okay. Now, squaring that matrix takes a little bit of work. Of course, we can get a calculator to square a matrix for us. I'm going to teach how to do that, but it's easy. Okay, just have to know how to enter it and square it. If I want the number next year at this time, I have two choices. Actually, more than two. We'll go with two choices. I can multiply 500, 500 by this matrix, then multiply the result by this matrix, this matrix, okay? I can keep multiplying by this matrix and do that 365 times. Okay? Nobody in their right mind is going to do that. But what I'm going to do is I'm going to say, we're going to have this. And that's going to approximately equal this. Now there's algebra to do to figure out why it's going to equal this. But we're not going to get into that. My point is, we can use a calculator in a minute or less. We know how to use it. We can enter these numbers in a matrix. We take that matrix to its 365th power and multiply it by 500, 500. Matter of fact, we can just enter this whole calculation in the calculator. Punch a button, and there it is in an item. Okay, and it'll give you, it's got to be like 666.66 and then some other numbers. 333.3. So, okay, this number will be twice as big as this number. And it comes out, the reason for that is this number is twice as big as this number. You got twice as many demented going sane as you got sane going to bed. Money I could say about that, and I would. In a normal year. Okay, but with COVID, disruptions and so forth, a little more than we can really get to. And it's more than is necessary for this course. We've decided here at this college that we are going to teach basic matrices and how to multiply, divide, add, and subtract. Okay. This is one thing that we can do. One example, and these transition matrices are very important. I have a couple of problems in the homework that involves. There'll be videos. It'll show you the mechanics of how to use. Okay. Other than that, it's mostly just doing augmented matrices we talked about last time. And adding and subtracting and multiplying matrices. So, for the most part, it shouldn't be too bad of an assignment. I just rearranged the assignment because the problem with videos came later than the problem that didn't have videos. And so I didn't realize that I had modified that assignment for it. I've got it so that the videos are there before you have to be problems about the videos. make sure you do the videos correctly. It starts out with a tutorial. So you have that available to you. And you should be able to do pretty well with it. Okay. Just a quick mention. No, take the time. Maybe next time we talk a little bit how we can transform space with matrices. Everybody's having way too much trouble with this. So we need to, even if you paid 95% or better on the assignment, we need some money. Okay. We need to be able to do this. We're gonna have a problem like this. Okay, so let's work this out. Here's the problem. I'm gonna choose to eliminate Z for the first two equations. Okay, so I'm using this notation. Equation 1, 2, 3. Going to multiply equation 1 by -3. That'll give me -6x. -3x minus 9y minus 3z equals -30. And then I'm going to write the second equation. 6x minus y plus 3z equals 15 times -15. When I add these two equations, x's go away as well as the z. Okay. Now, that can happen. Okay, now, that's what some people did, and I don't want to do that. Because it looks a little different than it usually does, although something we need to be able to deal with. Let's keep it looking. Like the one. Okay, so I'm going to multiply the first equation by 2. And write down the second equation. Okay, that's going to give me 4x plus 6y plus 2z equals 20. 6x minus 6y plus 3z equals -15. When I add these, straightforward add them, I get 10x plus 5z equals 5. Okay, this is the equation mx and p. I can't solve this. In other words, I can't get a unique solution for both x and z until I have another equation in x and z. So I'm going to need to eliminate y in a different equation. So what I'm going to do is I'm going to eliminate y between equation 1 and equation 3. And multiply 1 by -3 times equals 1. And then I write down equation 3. That gives me -6x minus 9y minus 3z equals -30. And 4x plus 9y minus 2z equals 25. When I add these two equations, I get -2x minus 5z equals -5. Okay, so now I've got two equations in x and z. So now I need to solve system We're gonna find what the force today. I write this system out, 10x plus 5z equals 5. Negative 2x minus 5z equals negative 5. Well, this comes out kind of neat. If I just add the two equations, z goes away. I don't have to do anything. So I end up with 8x equals 5 minus 5 is 0. So I can solve that. I divide both sides by 8. But 0 divided by 8 is still 0, so I get x equals 0. Now what's z? I can take that x equals 0 and plug it into either of these equations. I get 10x. No, I don't. I get 10 times 0 plus 5z equals 5. Well, 10 times 0 is 0. That's just 5z equals 5. And that has solution z equals 1. Now I've got numbers for x and z. I can plug them into any of the first three equations and solve for y. Which equation do you want? 1, 2, or 3? Hold up fingers, whatever. 2. Okay, I'm going to plug x and z into the second equation. I call that equation 2. So that gives me 6 times 0 minus 6y plus 3 times 1 equals negative 15. Well, this gives me 0. So I get minus 6y plus 3 equals negative 15. I add negative 3 to both sides. I get negative 6y equals negative 18. Divide both sides by negative 6. I get y equals 3. So there's my solution. Now, what's the process? The process is to reduce the system of 3 equations in 3 unknowns to 2 equations in 2 unknowns. To do that, I have to eliminate one of the variables from 2 different pairs of equations. So I chose equation 1 and equation 2, and I chose to eliminate y. There it is. There's the equation that resolves. It leaves me with an equation of x and z. Then I chose the first and third equations. And eliminated y. Gave me another equation in x and z. So now I've got it down to a system of 2 equations, which we learned to see before we started with equations 3 on. Okay. And we solve this system. Plug the numbers back in. We have a result. So we need to get need to keep working at this.